How's it going? Today I am going to show you how to print on the Monoprice Maker Select 3D printer. This printer is a great printer. It's a great price. I would really recommend buying one of these printers. Um, what I'm going to show you is how to install the software and use the software and to generate a G-code which your printer will read to print whatever you're trying to print. Alright, so the first thing that you want to do is to go to Google and type in Cura, C-U-R-A, and Cura is a free slicing software that most 3D printers can use. So when you type that in, you're going to select the second link, not the first link, the second link. And the second link is going to take you to a page where you have two options. You can either download Cura 2.1 or Cura 15.04. This is the one that we're going to download. This version of Cura allows a lot more customization to your print. So you can really control the quality of your print. And so we're going to download this, and I'm going to show you how to use it. And so once you've downloaded it, you're going to open it. And this tutorial works for either Windows or Mac. It's a little different process for downloading, but I'm sure that you have downloaded programs before on either device. And so when you download Cura, and like I said, it's going to look exactly the same on either a Windows or a Mac. So I've already previously downloaded Cura, and so I can't remember the first time you open Cura, it may do something a little different. But the first time you open it, it might bring you to a page that looks like this. Add New Machine Wizard. And if it doesn't, how to get to that page is you click on Machine and click on Add New Machine. This is what you're going to do to add the printer, the Monoprice printer. So click on this, and when you get the configuration wizard, click Next. Our printer is not on this list, so we're going to click Other, and then we're going to click Next. And the printer that we're going to select is the Prusa Mindel i3. So this is the actual printer that we're using. Monoprice buys this printer, puts their name on it, and sells it. This is a great printer. And so select that, click Finish. And so you have Cura open. And the bed size has been set, and I'm actually going to select this. The bed size has been set, and the nozzle size should be 0.4. If it's not, you should change it. The diameter should be 1.75. If it's not, you should change it. And we'll go over the options, the other options. And yeah, so to get an STL file, there's a few sites. My favorite is Thingiverse. Thingiverse is a place where people just open different cool things that they've made, like this arm or whatever it may be. You'd be surprised what you can find on here, things that are really applicable to a lot of projects where you might use 3D printing. And so click on Explore, Things, and then instead of exploring the newest, click on the most popular. And what we're going to download is this whistle right here. So click on Thing Files once the page downloads all the way, opens all the way, and download this STL file. So I have my STL files defaulted to open in Cura, but if you don't, then just drag it over to Cura, just open it through Cura. And when you open it, it should open really nicely, and if it doesn't, let's say it opens something like this. You know, we wouldn't want to print this whistle like this. It wouldn't print very nicely. And so what you're going to want to do is you're going to click on it, and you're going to click Lay Flat. So the Lay Flat button doesn't always work the first time. For example, it got a little closer, but it didn't quite do the whole job. So we're going to just adjust it a little, and then we're going to click Lay Flat again. So there we go. It got us back to where we started, and now it is ready to print. So there's three options on moving objects around on your build plate. You have Rotate, you have Scale, and you have Mirror. Mirror does exactly how it sounds. It mirrors your object. It does not duplicate it. Scale scales your object, and this is really important because sometimes when you export an STL file from a CAD software, it will confuse. If you made it in inches, it will think that the inches were millimeters, and so it will pull in your object and it will be crazy small. So you have to scale it to what you made it in. And the rotate, as you were seeing, does exactly that. It can rotate around all the three axes of rotation, and you can lay it flat. All right, so we're going to go over these different options, and I'm going to show you how they affect your print. So these three measurements right here are really important. The first one tells you how long it's going to take to print your object. This tells you the length of the amount of filament that you're using, and this tells you the weight or the mass of the filament that you're using. And so this would take 1 hour and 50 minutes to print about. And so the layer height is exactly how it sounds. You control how tall each individual layer are. The finer you get, for example, if I say 0.1, watch what happens to the time when it loads. Now it takes twice as long to print, which makes sense. It's half as tall. So I found the best layer height is 0.2 millimeters. This is great. I found if you go smaller, sometimes you'll get inconsistencies along your walls. The layers will kind of run over each other, or they just won't look as good. There could be some gaps or different things. 0.2 is more than fine for most applications that you'd be 3D printing stuff in. The shell thickness is obviously the thickness of the shell. You have two parts. Well, if we were to cut this whistle in half, what it would look like, actually, let's do it. We can go to layer mode, and we can look. And so if we bring this down right here, so you can see how this whistle is hollow on the inside. And you can see this little pattern. What this is called an infill. So an infill fills up the hollow parts of your print. And you can choose to adjust your infill density. Right now we have it at 30%. We could probably lower it to 20% and it would look just as good. So when you lower it to 20%, it cut off not much time on the print, just a little bit. But it will affect the stiffness of your print, how rigid your print is. And so the higher the density, the stiffer and the tougher your print. The lower the density, the more pliable your print is. So the bottom and top thickness layer is the very first layer and the very top layer, obviously. But this, I like having mine a little thick, and this should be a multiple of your layer height. And so, for example, if I did 1.23, oh, it does it. I don't know. Never mind. Just set it to 1.2. 1.2 is great. 1.2 works, and it is thick enough so your part won't warp. The print speed affects the quality of your print a lot. The quicker your print speed, the lower quality your print will be. For obvious reasons, it's just trying to print as fast. It can't be as accurate. 40 millimeters per second is just about right. If you want even higher quality, go a little bit lower. I wouldn't recommend going much higher than 40, at least on this printer. The print temperature for PLA, if you hover, it will tell you 210 degrees Celsius is usually used. For ABS, you want 230. For the print bed, you choose it. There's not too many recommendations. I found that 60 degrees Celsius works great. It makes it so your print doesn't warp, and it adheres well to the print bed. The support type, if you have overhangs, for example, let's go back to our normal view. This right here is an overhang. It is a part that's not supported by anything under it, and it's kind of just flat, just straight across. And our printer is literally just going to go straight across when it's printing. And sometimes these can sag or just not print very well unless you have supports. In this case, this overhang is really small. It's a really small distance. Our printer's not going to have a problem with it. But on bigger prints, if you have a large overhang, you're definitely going to want to use supports. The platform adhesion type. Let me show you what the three of these look like. So if we go back to these layer view, right now we don't have any. What we have is called a skirt. So a skirt is just a thin little line around our print. And the purpose of this line is to get the filament flowing through the nozzle before it starts printing the main object. And the second type is a brim. So let me show you what a brim looks like. So a brim is a lot thicker, kind of what we saw last time. This is a one layer thick, but it goes all the way up to the edge of our part. And this helps when you have, a brim really wouldn't do anything for this whistle. But if we had a part that we were trying to print that didn't have a lot of contact with the bed, we would definitely want to use a brim, because what a brim does is it increases the amount of surface area that is attached to the bed. So it can help adhesion and it can help stop warping on small little details that may be touching your print bed. And so the brim is my favorite, hands down, if I'm trying to prevent warping. And the third option is a raft. I'm not a huge fan of rafts. Some people love them. What a raft does, it actually doesn't show you very well on this because this just looks like a skirt, and so it might not show you. But what a raft does is it actually prints a probably a 4-layer thick little platform that then it prints your object on. And this helps prevent warping just like a brim does. But it uses a lot more filament. Notice our time went up. It'll take longer to print, and we use more filament. So it's not that I wouldn't recommend it. They're just not my favorite. There's definitely applications where you would use it. So these last options, the flow is the amount of filament that's being extruded through the nozzle. We definitely want it at 100%, not really any lower, not any higher. There's no reason. There may be different filament types where you'll see it's not coming through the nozzle all the way. It's having trouble extruding, so you might want to increase it. But for PLA and ABS, just keep it at 100%. The diameter is a property of the printer. So the diameter filament that our printer is going to take is 1.7 millimeters filament. And our nozzle size, like I was saying, is at 0.4. So don't change these. These should be set. If they're not what they are right here, then change them. And yeah, so the last thing that I'm going to talk about is this enable retraction. And so you want to enable retraction, and I'll tell you why in just a second. So click on this advanced side, and what this will do, this retraction will do, is, for example, these blue lines are where you're not printing. These blue lines is where your nozzle head is just traveling. So from right here all the way down to here. And so if you don't have retraction enabled, the extruder is just going to, what's going to happen is when it travels from here to here, you will get a spider-like web of plastic all around your part, all where there's blue, because you didn't retract your filament up inside the extruder before you moved it. And that's what this retraction will do. These are just the defaults. 4.5 millimeters is the distance that it retracts. This is the speed at which it retracts. I found this is the best. I wouldn't change it. Just keep that how it is. Make sure it's enabled, and it will increase the quality of your print a lot. You can definitely tell when a print has not been had retraction enabled. The last thing is plugins. You don't need to worry about this. Just make sure no plugins are enabled. Unless you want plugins enabled, you can pause at a certain height to change a filament if you want to. You can tweak the z-axis if you're having problems with that, but for our purposes, you don't really need to worry about it. And so once you have all of these set to what you want, I think these settings right here that I have are just great for the printer that we're using. So just copy these if you just want a good print. If you want to experiment, go ahead and change them. And yeah, and the last thing that you would need to do is save the G-code. So it says save toolpath. And so this will save wherever your STL file is. So if we click save, it's going to save right where my downloads was. And here's the G-code. I have 2 of them because I've done this a few times. But what you're going to do is you're going to take the SD card from the printer and you're going to load this G-code onto it. And voila, you just load that G-code onto the printer and it will start printing with all the settings that you've done. And that's it. Thanks so much for watching.